A black hole is a region of space where gravity is so strong that nothing can escape from it, not even light. It forms when an enormous amount of matter is concentrated into a very small space. The gravity there is so intense that even space and time become distorted. If a person could get close to a black hole, they would begin to experience very strange things. The first thing they would notice is that the universe around them would start to look unusual. The black hole's gravity bends light, so the stars would appear twisted and moving in strange ways. It would be like looking at the sky through a glass cup or a metal spoon where everything appears curved. Space itself would seem warped, as if it were made of rubber. As the person moved closer, something even more surprising would happen. Time would begin to behave differently. To someone far away observing through a telescope, it would seem as though the person were moving slower and slower as they approached the black hole, almost as if time itself were passing in slow motion. It would even appear as though they became nearly frozen right at the edge. But for the person falling in, nothing would feel unusual. Their watch would continue working normally, and time would seem to pass as it always had. Then comes one of the most extreme effects. Gravity does not pull equally on every part of the body. The part closer to the black hole would be pulled much more strongly than the part farther away. It would be as if someone grabbed your feet and pulled with enormous force while another person held your shoulders. That difference in force would begin stretching the body more and more. Scientists named this process spaghettification because the body stretches like a strand of spaghetti. If the black hole were very large, it might even be possible to cross a boundary called the event horizon without noticing anything special at that exact moment. It is like passing through an invisible doorway in space. There is no wall or sign telling you that you have crossed it, but that boundary is the point of no return. Once you pass through it, there is no way back out. Everything that enters becomes trapped forever. Not even light can escape. Eventually, everything would end at the center of the black hole, in a place called the singularity. It is a region so extreme that our current theories can no longer fully explain what happens there. It is as though the laws of physics we know stop working. Most likely, anything reaching that point would be completely destroyed by gravity, including us humans. For a long time, black holes were only an idea in mathematics. They emerged from the theories proposed by Albert Einstein in 1915 to explain how gravity works. Interestingly, Einstein himself was not sure such objects could really exist. He believed nature might somehow prevent the formation of something so extreme. But over time, observations and technology proved that black holes are real. Today we know that black holes not only exist, but also play a very important role in the formation and structure of galaxies. One of the most disturbing aspects of black holes is their effect on time. According to general relativity, gravity is not simply a force, but a curvature of the fabric of spacetime. Where gravity is stronger, time moves more slowly. This is not an optical illusion or a measurement error. It is a fundamental property of the universe. If we placed one clock near a black hole and another on Earth, we would see that the clock near the black hole ticks extraordinarily slowly. This concept, popularized in the movie Interstellar, is a real and scientifically confirmed phenomenon. The story of how we discovered black holes is fascinating. It began more than 200 years ago when two scientists imagined something called dark stars. They thought stars could exist with gravity so strong that not even light could escape. At the time, it was only an idea, and few people paid attention to it. Many years later, when Einstein better explained how gravity works, another German scientist made important calculations. While serving during World War I, he discovered that Einstein's equations also predicted the existence of an object with gravity so powerful that nothing could escape it. This scientist died shortly after sending his calculations, never knowing that he had helped describe what we now call black holes and the boundary surrounding them, the point beyond which there is no return. To understand how a black hole is born, we first have to think about the life of a very massive star. A star exists because it maintains a balance between two forces. On one side, the energy produced in its core pushes outward, and on the other, gravity tries to crush it inward. As long as the star has fuel, these forces remain balanced, and the star can shine for millions of years. But that balance does not last forever. When the star runs out of fuel, it no longer has enough force to resist its own gravity. Then its core collapses rapidly inward. In very massive stars, this collapse triggers a gigantic explosion called a supernova, which can briefly shine brighter than an entire galaxy. After the explosion, if the remaining core is still massive enough, it continues compressing more and more until it forms a black hole. At the center remains an extremely dense region, and around it appears an invisible boundary called the event horizon. That boundary is the point of no return. Once something crosses it, it cannot escape, not even light. That is why we cannot directly see a black hole. We can only detect it by observing how it affects everything around it. Many black holes are surrounded by rings of gas and dust. When a star or cloud of gas passes too close, the black hole's immense gravity begins pulling that material inward. But instead of falling directly into the center, the matter starts spinning around extremely fast, forming a giant whirlpool similar to water circling a drain. As it spins at such incredible speeds, the gas becomes compressed and heated until it begins to glow with intense light. This creates something fascinating. Although black holes are the darkest objects in the universe, they are often surrounded by some of the brightest rings of light that exist. Thanks to this glow, scientists can detect where these objects are located, even when they are millions of light years away from Earth. In fact, the first real image of a black hole, captured in 2019, showed exactly this bright ring surrounding its dark shadow. The year 2019 marked a historic milestone for humanity when the Event Horizon Telescope revealed the first direct image of the region surrounding a supermassive black hole at the center of Messier 87. It was not an artist's illustration or a computer simulation. It was real light that had traveled 55 million light-years to reach us. The image showed a glowing orange ring surrounding a dark central void. That void is the black hole's shadow, a region where light has either been swallowed or bent so strongly that it leaves a dark hole in the bright background. This technical achievement was equivalent to trying to photograph an orange on the surface of the moon from Earth. Soon afterward, the same team captured an image of Sagittarius A*, the black hole at the heart of our own Milky Way galaxy. Although much smaller than the one in Messier 87, it is still a monster containing 4 million times the mass of our Sun. These discoveries confirmed that nearly every large galaxy contains a giant black hole at its center, and that these objects play a crucial role in the evolution of galaxies by regulating the formation of new stars through their powerful jets of energy. Black holes are far more than simple gravitational traps. They represent the ultimate frontier of knowledge, the place where general relativity and quantum mechanics meet and conflict. They are the greatest challenge to the human mind, understanding something that, by definition, cannot truly be seen. Despite their reputation as cosmic destroyers, black holes are also creators and organizers. Without supermassive black holes, galaxies might never have formed the structures we see today. And without the deaths of the stars that came before them, we would not exist to observe them. Our fascination with black holes reflects humanity's natural curiosity. On a small planet inside an enormous galaxy, we have managed to discover and understand things about the universe that once seemed impossible. We have even photographed the shadow of a black hole and detected the moment when two of them collide in space. The universe may be vast, dark, and mysterious, but as long as we continue looking toward the sky and asking questions, we will always find new things to discover. Black holes are not the end of the story. but a new doorway into exploring the universe even further.